Hi everyone, welcome back to my math teaching today. In this lesson today, I will continue with the lesson yesterday, which is iteration. And I will show you a few more questions to perform the iteration in general. Generally speaking, in this topic, if you have a sheet of formula in front of you, your task will not be so tough. All what you have to do is plug in the formula, follow the formula, and perform your iteration. So this chapter is not so bad, but the next chapter will be more difficult. However, we still have some few lessons before we get into the next unit. So the next lesson I would like to show you is a new technique of iteration by substitution. But at this point, we should do the iteration using the formula. Okay, so if we have the first question, if we have sine theta, the antiderivative side will be minus cos theta. Okay, so if we have sine theta, the antiderivative will be minus cos theta. So I will have a minus 3 and cos theta minus the antiderivative of secant square theta is tan theta. So minus is minus tan theta. And we have an angle on the pi over 4, on the top pi over 3. Remember, we use this f of b minus f of a. That is yesterday we learned. So now we do exactly the same thing. So we substitute the angle theta by this angle. We have minus 3 cos of pi over 3 minus 10 of pi over 3. Now this bracket will be subtract. The next angle will be pi over 4. So we substitute in exactly the same function, right? Now we go for f of a. And f of a is this angle. So minus 3 cos of pi over 4 minus 10 of pi over 4. So now we have to remember Spencer triangle, right? If you have a triangle, opposite with square root of 3 is the angle 60 degrees, which is the same like pi over 3. And this is 1 and this is 2. So the ratio for this is cos is adjacent over hypotenuse. So minus 3 times with 1 over 2. Minus 3 times with 1 over 2, which is minus 3 over 2. And so we evaluate done with that. Now we go for this one. 10 pi over 3 is opposite over adjacent. So our opposite is square root 3. Adjacent is 1. So minus square root 3. Bracket minus. Now we go for the next bracket. The next bracket is the angle pi over 4. So cos of pi over 4 equals 1 over square root 2. If we do rationalize denominator, we got square root 2 over 2. This value is exactly the same. And I like to use this value, so I'm going to get rid of that. And now minus, we have a 3 here, so minus 3 times with square root of 2 over 2. So cos of square root of pi over 4 is square root 2 over 2. We time with minus 3 here. So that's it look like. And minus 10 pi over 4. 10 over 4 equals 1 because it's angle 45 degrees. And the side the same as the cos. 10 equals sine divided by cos. Same number divide, get 1. So minus 1. So now We simplify this a little bit. When we simplify, I can put the two numbers with the same denominator together. So I will get minus 3 over 2. Minus times minus is n. So this number is n. 3 is square root 2 over 2. And this is minus square root 3. And this is minus times minus is n at 1. So let's write it in a decent way a little bit. So that will be equal minus 3 adding with 3 square root 2 all of them over 2. And this should leave it for now. That is our answer. Now we're going to do the second question. And for the second question, you will do a little bit of manipulation, right? First, I will turn this into a rational power. So this is root 4. When I turn to rational power, it will look like this. X to power 1 over denominator is power root 4. So the bottom is the root and the top is the power. The power here is power 1. So 1 over 4, the same like this value, you write like rational power. Now I'm going to bring this number up here. But when I bring it up here, positive power becomes negative power. So that a negative power rules in math. So you have, I'm going to simplify this one. I'm going to put in the bracket. And this, I bring it up. So it looks like that, minus 1 over 4 dx. So that's how I manipulate that question. Now I'm going to iterate this one. But before I iterate that, I have to simplify further one more step. I'm going to distribute this inside the bracket time with this first one. Now the first is power 1. Adding, when you multiply the same base, you add power. Adding with minus 1 over 4, the same like subtract 1 over 4. Do common denominator, 4 minus 1 is 3 over 4. So this number is like that. So the x will become, when you multiply them together, they become a power 3 over 4. The next one, I distribute to the next number. So that equal minus 5 x to minus 1 over 4 dx. So now I'm going to integrate this. Now, when you do antiderivative, remember the power rule, we have to put 1 underneath, divide 3 over 4. But 3 over 4 here have to add back into 1. That's how we do power rules in antiderivative. So do common denominator, this number will become 7 over 4. Now 1 divided by 7 over 4, the same like you twist 4 over 7. So 4 over 7x, and the power will be 7 over 4. For this one will be minus 5 divided with minus 1 over 4, add to 1 equal 3 over 4. Now 5 divided by 3 over 4, the same like 5 times with 4 over 3. So that 20 over 3. So this number will become 20 over 3. And the x minus 1 over 4 add to 1 power will be 3 over 4 plus c. So that's the answer for the second question. Now I'm going to go to the next one. So the first question, so in this lesson today, I mixed up between sometimes we do evaluation like that, and sometimes we just perform the antiderivative like this. If it doesn't give us an A here and a B on top here, right? So it's nothing we can do except just do antiderivative. The same like here. This trick requires a little bit trigonometry background and the formula. Now formula is easy. I just type it in the sheet and put it in a beautiful MS PowerPoint and install in my school online, the website, my course online. If you register into this, you can have access with all the formula. I make sure that before I type in the formula, I check with on other formula paper as well from other authors as well. Make sure we have the right formula. I won't type in the give you a wrong formula. Or I can download from the internet directly, right? You can do that as well. And you can compare, you can see if I give you a wrong formula or the right formula. We have access to Google everything nowadays, so that's not a big deal. So anyway, I remember the formula, but I don't expect you to remember the formula. If you remember, that's great. So now let's do the first iteration first. So the first will be adding to 1 will be x to the power 5. 5 divided by 5 is just 1. So I'm going to say this is just x to the power 5. The formula say if you have an original function, the derivative function of cosecant x, cot x, will be equal minus cosecant x. And minus, but we have a minus here. So minus times minus formula will become n. So I'm going to put the n, right? The formula say it minus. However, because you have a negative of the function already here, so negative times negative will become positive. So positive 2 times with cosecant x. So the whole thing here, when you derivative, it becomes like that. And yes, and that is our answer. Easy. So we don't have any evaluation here, just that the answer. Let's see. Now the last question may be longer a little bit, so I have to the last question I have to need more room. So I'm just erase this. Okay, so this is the last question today, and tomorrow I will show you the next topic, right, which is iteration by substitution. So when I do this question, I would like to distribute inside the bracket first. So that's I will do. So 0, 64. Now this one will become this time that is just exactly the same, right? Square root y. And this time this will be adding with square root y times with the third root of square root y together. Now they are not the same, right? This is square root, this is third root. Okay. Okay, so that's how it looked like, and this is dy. So what should I do? Okay, now what I'm going to do, I'm going to turn this into rational power again. Yeah, because for iteration we should. So I'm going to say this is y to the power 1/2, adding with this will be, let's see if you see the or no, yeah. So the next one will be y to the power 1/2 time with, and I put a dot as the time, y with the power 1/3. Now, when they are multiplied, you're allowed to simplify them, right? So now we can simplify further. So we have y to the power 1/2. Now this one we cannot do. Make sure you know the operation, right? This is multiply, we can simplify it. This is adding. So you cannot apply the law of the power to the adding expression like that. But for multiply, yes, when you multiply the power, the number with the same base, you add power. So we have 1/2 adding with 1/3. And the power here is times 3, the denominator. So that will give us 3 add 2 is 5/6. So 5/6 is our power now. So y will be 5/6 and the CDY. Okay. And make sure we iterate from 0 to 64. So now, and I make sure I don't forget, right? This is adding. So this should be adding. So now the answer will be, let's do iterate right away. 1/2 at 1 is the power 3/2. So we have y to the power 3/2. And 3/2, when we twist this, become 2/3. Right, for this one. Now for this one will be 5/6, add into 1 will be 11/6. And when we reverse this here will be 6/11, y 11/6 plus c. That is our answer for the antiderivative, but we still have to evaluate. Z go from 0 to 64. Now we do FB minus FA like this, right? So our FB will be 2/3. Our Y will substitute by 64 and 3/2. 3/2 is easy to turn it into square root of 2 of 64, and we power it back by the top here, power 3. Okay, so now adding with 6/11, and the y we substitute by 64, and again we're going to turn this into root of 6 because our root is 6, right? And we're going to power 11. Now the c, we don't have any values, so don't worry about that. Subtract. Now this is 0. If you substitute 0 in here and you substitute 0, 0 times with anything, it's just 0. So it doesn't matter. So reduce the task for us a little bit. We don't have to worry about this part because 0 times y, substitute y equals 0 times with anything is just 0. So that is our answer, but we have to simplify a little bit. And how do we simplify? So 2/3 is still 2/3. Square root of 64 is 8. 8 times 8 is 64. Power 3. Adding 6/11. The 6th root of 64 is 2 because 2 to the power 6 equals 64. 2 to the power 5 equals 32. So 2 to the power 6 is 64. Take the root, go back to the base, which is 2. So this number is 2 and power 11. So at this point, we have to do a little bit of using calculator. So this is 2/3 times with a to the power 3. A to the power 3 will be a big number. A to the power 3, which is 512. 512. So that done with this one. Now go next one. Will be 6/11 times with 2 to the power 11. Again, it's a big number. 2,048 to the power 11. So 2048. Now first, I'm going to try to divide by, I don't think I can divide by 11. but let's see. What do we get? Okay, in this case, maybe we have to, okay, let's multiply and see. If I have 6, I time with 2048, we get this number. Now I divide by 11. It will give me a decimal for sure. So that's the answer for that one. So this have the answer of 1117.1. I draw up. Okay, so that's for that one. Now the other one, 512 divided by 3, or 512 times with 2 divided by 3, you got 341.33. So 341.33, adding with this number. So the whole thing, we're adding with 111.7.1, will give us 1458.43. So the answer is 1458.43. So that is a decimal answer. We have to cut off the rest. Now, you also can keep the exact value by do common denominator, right? So if we do that, this you have to time with 11 here, and top you have to time with 11 here. And this you have to time with 3 and top. And you can do that as well. However, because the denominator is too big, I don't want to do that. But yeah, so that is the answer. Now, if you want to do the common denominator, you can work at this here, little summary for that. If we do that, we'll get 22 here. So we get 22 times with 512. All of them over 3 times 11 will be 33. Adding with 6 times 3 is 18. 18 times with 2048. All of them over 33. We can do that as well. And that will give us what number? 22 times 512, 11264, 11264, adding with 18 times with 2048 equal 36864. All of them divide by 33, the same common denominator. So let's add them, 11,264. Now divide by 33. You got the same answer. See that? So it doesn't matter which one you want to do. You also might be able to reduce the low fraction as well, but it takes time. Anyway, I show you how to do the iteration generally. So tomorrow we'll get right into the lesson of iteration by substitution. And that will be fun. So thank you for watching. Bye for now.